Hello. So today we'll talk about cholesterol metabolism. This is also an essay question. So we'll identify introduction, the cholesterol metabolism and the applied aspect. Now, what is cholesterol? So it is a 27 carbon compound which is in our body in the trace amounts. Okay. Normal cholesterol 150 to 200 milligram per deciliter. And what is the ring is C triple P, cyclopentanoperhydrophenanthrin ring. Mouthful name, but please, very important, please remember this C triple P ring. It is very important in the biochemistry spotters. So I will show the picture in a few minutes. Before that, the functions. It is a part of biological membranes and the synthesis of steroid hormones, bile acids, vitamin D in LCAT metabolism, and it's also a neurotransmitter. So this is the structure of cholesterol. You can see now 27 carbon atoms are there. Okay. So please practice this structure, and this is very important. In the spotters, definitely this will come. Cholesterol. Okay. Now we'll see the biosynthesis. So as usual, from ketogenesis, two molecules of acetyl-CoA combine on thiolase. CoA-SH is released, or acetoacetyl-CoA synthase. We will get acetoacetyl-CoA. Then on HMG-CoA synthase, acetyl-CoA to CoA-SH, we will get HMG-CoA. Beta-hydroxy, beta-methyl, glutaryl-CoA. Okay. Now, so HMG-CoA on reductase, there we had lyase and ketogenesis, here reductase. From here it is no way connected to ketogenesis. NADPH2 to NADP plus will get mevalonate. Here mevalonate. Okay. And on kinase 5-phosphomevalonate. Again on kinase 5-pyrophosphomevalonate. Again on kinase 3-phospho-5-pyrophosphomevalonate. So wherever the kinase is coming, ATP ADP should mention. And then 3-phospho-5-pyrophosphomevalonate on decarboxylation IPP, isopentenyl pyrophosphate. Then on isomerase it forms dimethyl allyl pyrophosphate. Okay. On cisprenyl transferase, it is cisprenyl transferase actually, will get GPP, geranyl pyrophosphate. On cisprenyl transferase, farnesyl pyrophosphate, FPP. On squalene synthase, NADPH2 to NADP plus, oxygen to water, will get squalene. Then squalene, once again NADP plus to NADPH2 will get what? We will get lanosterol. And on another 19 more reactions, we'll get cholesterol. So just after squalene, remember lanosterol, cholesterol. That is enough. There are more 19 to 20 reactions. Okay. Those are all not important, but important is lanosterol to cholesterol. Last step. Now, let us see the applications, the LCAT, which I said. So LCAT is actually lecithin cholesterol acyltransferase. This is important for HDL transport or HDL metabolism. Okay. So what happens? Lysophosphatidyl becomes phosphatidylcholine. Just remove the lyso. That's all. And cholesterol ester or cholesterol ester becomes cholesterol. So important to remove the bad cholesterol from the body, which is present as cholesterol ester. That is LCAT. Then the bile acids. So cholesterol on 2 and 3 hydroxylations. So on left 3 and right 2. So please write down on 3 hydroxylations, cholesterol 3712 diol. On 2 hydroxylations, cholesterol 37 diol. Then on propionyl CoA, we'll get collyl-CoA and chenodeoxy-collyl-CoA, then on CoA SH, cholic acid, and then chenodeoxy-cholic acid. Okay, then addition of glycine or taurine will get glycocholic acid and glycochenodeoxycholic acid. The same with taurine as well. Now, for steroid hormones, what are the steroid hormones? Like progesterone, cortisol, aldosterone, estradiol. So we need to remember this is the precursor after cholesterol, that is pregnenolone. Okay. Then this is vitamin D in the skin. In the skin, 7-dehydrocholesterol is present. When light comes into it, we'll get CC, cholecalciferol, vitamin D3. Then on 25 alpha hydroxylase, we will get 25 OHCC or 25 hydroxy cholecalciferol. Then on 1 alpha hydroxylase, 125 DHCC or 125 dihydroxy cholecalciferol or calciferol, or just simply calciferol. Okay, so remember that the first step occurs in the liver and the second step in the kidney. Exactly opposite, we will see in the glycine metabolism, where the first step is in the kidney, the second step is in the liver. Now, so this is the regulation of the cholesterol biosynthesis. Okay, this is to show the gene. There is a central dogma happening, transcription, translation. Okay, then we are getting HMG-CoA reductase, that is becoming HMG-CoA to mevalonate. So promoters are insulin thyroxine here, and these are the inhibitors, glucagon and cortisolic hormones. Okay, same thing I already explained. This is to show HMG-CoA cholesterol. This is a thing. Then applied aspect, we have enterohepatic circulation, cholelithiasis, plasma cholesterol, then hyper and hypocholesterolemia. Now, what you mean by enterohepatic circulation? Hepatic means liver. So remember that the glycine taurine salts are made in the liver. They're made in the liver and released in the intestine when the fat molecules will come. So this is important for fat metabolism in the intestine. And daily, how much of bile is secreted is 15 to 30. Just remember 15, double of it is 30 grams per day is the secretion. Excretion is just half a gram, 0.5 grams per day. Okay. Another easy way to remember, 15 by 30 is 0.5. So 0.5 grams per day. In the stools, if this excretion rate is more, it leads to a condition called as steatorrhea. Fatty stools, I should say. Then cholelithiasis, nothing but gallstone disease. Okay, it is an impairment in the bile salts metabolism. Okay, and for this we will administer chenodiol. But there are patients who are resistant to chenodiol as well. That is another point. And if this goes severe, surgery may be required. Okay. Then we'll try to identify plasma cholesterol. So why is it low in the women is estrogen. Please remember that hormone, estrogen. Okay. And it is associated with the lipoprotein fractions. So what are they? VLDL, LDL, HDL. Okay. Chylomicrons and then free fatty acid albumin. This five are very, very important. And it is estimated through the Fredwald's equation. We can get the bad cholesterol from this. That is LDL is equal to the total cholesterol minus of HDL plus 1/5 the triglycerides. So before we move ahead, a short note on LDL and HDL. LDL is called is a bad cholesterol. So it is also called as lethally dangerous lipoprotein. It leads to atherosclerosis because it's a proatherogenic factor. It's directly related to the atherogenic factor. HDL is a good cholesterol, also called as highly desirable lipoprotein. Okay, that's the thing. Clear? And it is anti-atherogenic. That's the point. And then hypercholesterolemia, as the name is evident from increased cholesterol in the blood. Okay. So how to control is consumption of PUFA, dietary fibers and plant sterols, good lifestyle, that means having exercise, eating proper diet, balanced diet, okay, like it, and bad lifestyle should not be practiced like smoking, drinking, alcohol, chewing gutka, pan and tobacco, etc. That comes under bad lifestyle. And when we take the diet, we should have equally all carbohydrates, fats and all. Not, it should not be like carbohydrates is more and the rest are less. That should be strictly avoided. And where does it seen? Where is it seen? Nephrotic syndrome, obstructive jaundice, DM as in diabetes mellitus, and hypothyroidism. Now, hypocholesterolemia. It is observed importantly in hyperthyroidism, MAS as in malabsorption syndrome, and pernicious and hemolytic anemia. So references from where I took the images: Satyanarayana Biochemistry 3rd edition, Vasudevan 6th edition. So that brings us to the end of the video, and thank you so much. I will see you in the next video.